Hello.
Hello, we're back
How are you?
again.
How's it going?
Yeah, doing good, thanks. How are you?
I'm good. I'm good. No complaints. No complaints. Uh,
Excellent.
are we gonna be honest with our audience or no?
I think we should
We should.
finally,
We should. Okay, you gave it a little bit
finally.
of thought there. You gave it a little bit of thought, but made the right decision. Uh, because we had just before we started recording, like, should we rehearse our banter? And we said no. So we'll see how it goes. May come crashing down terribly, but hopefully not. Hopefully not.
What can we say?
All right. So what do you got there behind you? I see some
Yes,
very
it's
intimidating, very intimidating big Greek letters in this
yes, it's a
big
little bit
division.
too big for the background
So
behind
that's
me.
okay. We want to get the point across. So we're coming in
Yes.
really, really big. So I know what it is. I know what it is. So I'm not going to pretend like I don't know what it is. That's correlation, right?
It is.
It
This
is.
is the formula to calculate Pearson's R correlation. Do you know much about Pearson?
I no, I don't actually like a history. No,
Yes.
no, no, I don't. I don't. Go ahead.
He's got a couple of fancy things to do with him. He founded the first ever Department of Statistics at a UK university. That was at UCL.
Wow, no kidding.
Um, yeah, he was also, oh, what else was he? He also employed many female statisticians to work with him as his assistant. So
Well,
he was a good
well done.
pioneer, yes, for women
Okay,
in
well, that's
science and
good. That's
maths.
good. That's good. That's awesome, and giving people an opportunity that may not have had it before, or didn't
Exactly.
deserve the recognition, or deserve the recognition. That's wonderful. That's great. That's great.
Yes.
Wow. All right. Well, I mean, now I feel bad for not knowing. I'm a statistician
No,
specifically, and I'm like, oh man, I should have known that actually. Oh well. Well, that's okay. So there's a different type of correlation coefficient as well, right?
Mhm.
And that's the Spearman,
Yes.
right? The Spearman correlation coefficient. And so we may wanted to talk about to decide when we use one, when we use the other, and how they're
Yes.
calculated, basically, right?
Yes. Sounds good.
All right. So yeah. So the main difference between the two would be what? Huh?
Well, I know that Pearson's R is calculated with the difference of X and Y specifically, but Spearman's uses ranks, doesn't it?
Right. Exactly right.
Mm.
Exactly right. So for a Pearson correlation coefficient, you're basically looking at how well a line fits the points. A straight line fits points between a independent X and a dependent Y.
Hmm.
So there's a line that's involved there, right? Okay.
Yes.
But in certain cases, we really can't, there's certain assumptions that aren't met where we might have to use something different than actually figuring out the difference between the X's and the Y's and using that fancy equation behind you there.
Hmm.
In fact, I'm going to try to, I'm going to try to write it on the
Sure.
whiteboard so we can see the whole thing and kind of explain what it is.
Hmm.
And then we'll go on to Spearman. Okay, so sorry, I have to plug in
Oh
my,
no.
yeah, let's see if it works, see how my handwriting works too. Sometimes it's good, sometimes not so good. I'm going to blame it on the pad. Where are we? Here we go. Sometimes the upgrades change the buttons,
Yep.
or I just don't remember where they are. All right. So I've seen in certain videos, okay, of ours that sometimes there's a little bit of a lag. So
Right.
I'm going to write this out and then give a little bit of time to make sure that it's showing up. Okay.
Sure.
So rho is what we use, I believe, right?
Hmm.
And that's equal to there's a give me 2 seconds here. There is a
Starts off with a one minus, I believe. Is that right?
well, actually, I was going to do the Pearson correlation coefficient.
Oh, right. Of
Right, right,
course.
right.
Yes.
Okay. So basically, the sum, what I have here is the sum going from I equal 1 to n
Mm-hmm.
of our mean of x, sorry, our actual value of x minus the mean of those x's, x bar, okay, that difference multiplied by the same thing done for the y's, okay, minus their mean, and that's being divided by, okay, square root. I got a really, is it a really big square root here?
It is, yes.
Here they show
Sometimes.
it as 2 square roots.
Ooh.
So here it's the summation. Again, I going from 1 to n, and I'm going to drop these, how do you call it? These indices, because they're going to be going from 1 all the way up to however big our sample size is.
Mm-hmm.
And then here, what we're taking the difference of is, oh, okay, so here I see what's happening. Here we have x, our x of i's minus their mean collectively squared. So I'm summing up the differences squared between
Yes.
the actual point and the mean that they have, the mean of those particular points, the mean of the x's in that case. Same thing here. Well, 1 to n of same business for the y's. Right?
Mm-hmm.
Okay, so there's that bit. That bit is squared as well. So this is going to give us a correlation coefficient where we have a specific line going through and actually calculating how well correlated the x's are with the y's. Okay, and then according to what's how many points there are, there's a certain level that our degrees of freedom need. Sorry, there's a certain degrees of freedom associated with the amount of points we have,
Mm-hmm.
and according to those degrees of freedom, there's a minimal amount that our correlation coefficient needs to be in order to show that it's significant. Does that sound right?
It does,
Okay.
yes.
All right. Maybe we should pop up a. I think you've mentioned in another video, actually. I think we have gone over how to specifically find if there's significance, um, if there's significant correlation between the x and the y. I think that we've discussed that before.
I think that does ring a bell, doesn't
Yeah,
it?
okay, all right, so we'll have people find that in another video. Okay,
Indeed.
so this is what we're basically doing when we're looking for a line, the correlation and how well that line fits the x's and the y's. Okay,
Mm-hmm.
can't always do that because our one of the things that we assume is that our data is our y's specifically are what, if we're able to use this. I think it's that they're normally distributed.
Yes.
Yes, yes. So when you've got data with some outliers, right, you're not necessarily going to have a normal distribution, and you may not be able to rely on the Pearson correlation coefficient. Okay.
Indeed.
So that's where we have to go on to the Spearman correlation coefficient, right?
Yes.
All right. So I think, I don't think I know that. I'm going to stop this share real quick. Okay. And let me see. I think I have a picture of it somewhere. Let me make sure that I have it available for us. And let me share this. So, Spearman, okay, let me pop that up so people can see what we're talking about. Okay, we see that?
Yep.
All
That's
right,
it.
cool. So, there's obviously there needs to be a 6 in there, doesn't there? I'm being sarcastic, of course, can you tell? We kind of discussed this before the video and said it's weird that there's that 6 up there.
Yes.
Yeah.
Someone much smarter than I has figured that out, decided, yes, we need a
I,
6. Why not?
I don't know. You know what? You know what? Here's something that I don't know if it has anything to do with it, to be honest with you.
Okay.
But when you have something being squared, right? You have
Mm-hmm.
something being squared. Um, let me make sure I'm saying this correctly. Um, we have something being squared, okay, I start to think of x squared plus y squared equals r squared.
Okay,
I'm really digging here. So x squared plus y squared equals r squared is an equation for what?
it sounds like a Fermat's last theorem, hypotenuse sort of question.
Well, it's a Pythagorean theorem, it seems like, right?
Ah, yes.
Does. But more
I didn't mean Fermat actually.
specifically, but more specifically, that r squared.
That is our hypotenuse. Is that what you mean? Or are
It
you referring
is,
to the
but since
Pearson?
I'm using r, why would I be using r? X squared plus y squared equals r squared.
Well, that would be our line of best fit between our
Not a
X and
line of
Y's.
best fit.
Oh
Not a line
no,
of best fit.
we should have rehearsed this.
No, I know. I
Please
mean,
tell me.
I'm kind of quizzing you right now. I'm sorry to put you on the spot, Laura. It's the equation of a circle
Oh, right, of
that's
course.
centered, and of course, that has to do with it's a vague question. I'm like r, and thinking, radius, but yeah,
Got it.
it's a circle that's centered at the origin,
Mm-hmm.
and you're describing every one of the points
Mm-hmm.
by its x and its y, and you're relating it to the radius of that circle, r being the radius of that circle. Okay, now again, this is kind of a stretch. If you take and you draw a circle with a compass, right?
Mm-hmm.
You're able to mark off exactly 6 equidistant points to make a perfect regular hexagon in that circle.
Oh, nice.
So there's 6. I don't know if it has anything to do with it,
Okay.
but I don't know. I don't know. Maybe it's a stab in the dark. Anyway, a little
Oh,
bit of a maybe, possibly a reason that that's a 6.
well, to be honest, I don't really know much about Spearman at all, but I'm gonna
Yeah.
have to look him up now and see if he was a guy into circles.
Yeah, possibly. But again, that's really dangerous. Anyway, okay, so what they're doing here is basically looking at, okay, so 1 minus the 6 times the sum of the d sub I squareds, where d sub I is the difference between 2 ranks of each observation. So basically we have an ordered pairs, and we rank what those numbers are. And if the top one in the first column ranks number one, and the top one in the second column ranks number one, they'd both be ranked, that would be the ranks that we're talking about.
Mm.
But what if they have different ranks? What if one specifically in one column is ranked with the second one in the second column, or sorry, with the as the second rank in the second column.
Mm.
So instead of one first rank and first rank, it's first rank pairing up the second rank. So we're looking at the ranks between those specifically.
Yes.
Okay, so we're summing up across every single one of those ranks, right? So let me see if I can actually draw here. If I can draw, that would be cool. There we are. Annotate. So, so if we're taking, let's say if the certain number ranks as number one here, right? Oops, why is that not drawing? Oh, that's not drawing for me.
I can't see
Anyway,
anything either.
anyway, I'm going to stop this share real quick. We have the Spearman correlation coefficient. D sub I is the difference between ranks of each observation, and N is the number of observations. Okay, all right, I'm going to go back to the whiteboard real quick, write it down,
Okay.
and then we can kind of give an example of that. And if we have time, we can also maybe even bring up our video and do a comparison between Spearman and Pearson on a
Nice.
specific data. Okay. All right, it looks like it's up, right? Okay.
Mm-hmm.
All right, so rho in this case is equal to 1 minus 6 times the summation of the differences squared divided by n times n squared minus 1.
Okay.
Okay, all right, so that's our correlation coefficient right here, our Spearman correlation coefficient.
Mhm.
N, that's number in our sample. And D again, we said is the differences. So basically, let's say if I have let's say I have a list here, and it's let's say I have an X and a Y. Okay.
Okay.
And let's say I have 100, 200, 300, and 400. And let's say here I have, I don't know, 200, 300, 100, and 400, let's say, something
Okay.
like that. Okay. So here, if we were looking at ranking them from smallest amount to biggest amount, right? I can say that the ranks here, right? The rank, let's say, rank. Sorry, rank for the rank for X and the rank for Y, right?
Mhm.
Oops, damn, that looks terrible. Rank.
That's okay. Is that meant to be a Y in the second column?
Yes, thank you. Y over here.
There we go.
So let's say we're going from least to greatest value. So this would be
Okay.
1, 2, 3, 4. Correct?
Okay.
Okay. Here, this would be 2,
Hmm.
3, 1, and 4.
Nice.
So our D's would be just this difference here. That would be 1 minus 2 squared plus 2 minus 3 squared plus 3 minus 1 squared plus 4 minus 4 squared. That's what we would end up top here.
Nice.
That makes sense?
Hmm.
And then N is just in this particular case, 4. So we'd be
Hmm.
dividing that by 4 times 4 squared minus 1. So 4 times 15. Is that right?
Hmm. Yep.
So that's what would give us our correlation coefficient, our Spearman correlation coefficient.
Nice.
All right, cool. So let's should we do this? Let's if we have time, do you think we should
Absolutely.
all right, let's open up our studio then. And I'm gonna have to go switch back to my mouse instead of my pad.
Incredibly cool you've got these gadgets.
Yeah, I know, man. The huge budget that we have over at no, I'm just kidding. Well, I mean they do okay at the University of Glasgow, but yes. Yeah,
That's good.
they don't leave us without technology, that's for sure. So
That's good.
we can't complain. Well, we could complain, but we'd be wrong in complaining. All right, let me pop up our studio, and I'm gonna use one of my favorite data sets,
Sure.
which involves cars.
Excellent.
So so it's like cars from like 1970s. So you see some
Ooh,
crazy models that they talk about crazy models that aren't around anymore, and the terrible gas mileage that they used to have. All right, here we go. Let me clean this up a little bit and then I'll share it that way. Look a little bit nicer. All right. Share. Here we are. All right. Okay, we see that? Is
not
that
quite.
is
There
it
we go.
popping up for us? Okay, that's cool. It's popping up for us. All right. So is it big enough? Can you see the text okay?
Yes, thank you.
All right, sure. All right, so there's a data set. Okay, so I'm creating a data set called DAT, and
Hmm.
there's some embedded data sets within our studio. One is MT cars, motor trend car test road tests.
Fantastic.
Got some pretty decent, got some fun stuff in here. Okay, so let's say, so this data set, just to remind everybody in case they haven't seen it. Okay, oops, let me make this a little bit bigger and rerun it so people can see it better.
Okay.
Let's do that. All right, here it is. Let me open up nice and big, and we see there's a bunch of data here. that involves miles per gallon, cylinders, displacement, I think that means, and some other metrics within a car that
Sure.
seem to be important, okay? So we can say, all right, let's do a correlation of a Pearson correlation coefficient to find out if we're going to fit a line, that line fits.
Right.
So we can ask for, I believe it's just correlation test. Is it correlation? Let's start typing. Core test, I think it is. All right, so this correlation, variance, and covariance matrices, that's not what we want. Test for associated correlation between paired samples. That's
Nice.
what we want. Yeah, so this particular test, and as we do in our studio, when we type when we type our data frame, that we've created in this particular case, and then a dollar sign, you get all the different listings here. So let's actually see how miles per gallon, okay? So this gives us miles per gallon in this particular column. So if it was to highlight that and run that, just to convince everybody,
Mm-hmm.
you can see all the miles per gallon down here. Okay,
Nice.
well, I need to compare it to something, right? So
Mm-hmm.
I'll put a comma and then my data frame again, dollar sign. Which one would you like to see? Horsepower, quarter mile in seconds, displacement. I don't know what that is. I don't even know if it really means displacement. I'm just guessing.
Well, let's go with horsepower then.
Horsepower, that's what I would go. Yeah, you do think there might be a correlation here, right? The
Yeah.
bigger the horsepower, what would you expect with the miles per gallon?
Oh, let's see, this is where I show my ignorance about cars.
Okay, horsepower is a powerful car.
Okay.
How do you think it's going to do on gas?
So I
Petrol?
think that's probably gonna go not very well on gas,
No.
possibly.
So probably a negative correlation here, I'd met,
Right.
if any at all. Let's see. Right. So, well, here we
Hey.
have a value that it's giving us
Mm-hmm.
happens to be negative 0.77 6, right?
Right.
Well, we could check a correlation coefficient. We could check this correlation coefficient against the data that we have to see if it's significant correlation.
Okay.
So let's do that. How many or let's actually, yeah, let's do that. Uh, but I think I'm pretty sure. Let me try something different here. I'm going to actually I'm going to create something that happens to be a correlation test and then ask for a
Okay.
summary on it. Maybe it'll give us some p-values
Ooh, okay.
because it's the p-values that we can look at directly and see if there's correlation, right?
Mm-hmm.
Here, pretty sure there's significant correlation because there's a lot of points, right?
Mm-hmm.
And the more points that you have, the more data that you have, the lower your correlation coefficient needs to be. The 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 closer to zero it could be, and you can still have significant correlation, right? You don't have to
Great.
be at 0.9 or negative 0.9 if you have a lot of points to show that there's significant correlation. So let's see if this will work. This is really, I'm just trying this to see if because I think it's worked in, maybe it's worked, or maybe I saw it in a dream. I don't know.
Only
But
one way to find out.
well, test actually has a bunch of stuff on it because it's got
Ooh.
some different things here. Fingers crossed. Oh, geez, what the hell is that? Yeah, that's
Ooh.
stuff that we don't estimate. Oh, p-value. What is it? Non-numeric? Let's try this. Let's try this. Test, dollar sign, p-value. Bam, look at that.
Ooh.
Because when you,
Excellent.
because when you, that's why it's so nice to use our studio, because when you create, I mean, there's really a lot of information that's very available. Okay.
Mm-hmm.
Like when we go in and we just created, there's something called correlation test. All right. There's certain things that have to go into it to be able to calculate that specifically. Right.
Mm-hmm.
So here's all the different attributes that this particular object has that we can draw if we need. So p-value, let's have a look at that. Yeah, that's significant correlation because it's well under 5%, isn't it?
Mm-hmm.
All right. Okay, right. I'm glad we did that.
Hey, very
Very
nice.
cool, very cool. Well, let's actually see if we can run a Spearman correlation, right?
Sure.
Because I think under core test, no, I think we can put in method and it'll allow us to figure out the Spearman. I may be wrong on that, but let's try it.
Okay.
So I'm going to copy that, paste it. I'm going to try an option here, comma. I'm going to start typing method. There it comes up, didn't it? Method.
Oh, nice.
Nice. And it says one of the three, Spearman, Kendall, or sorry, Pearson, Spearman, or Kendall. So let's go with, in quotes, Spearman. And I have to make sure I spell it correctly too.
Hmm.
Spearman. Spearman. Oops, wrong.
Oops.
Spearman. There we are.
There we go.
Spearman? Okay. Let's see if that works. It'll give us an error if that's not correct. An error. Okay.
Oh,
There we go. Method. No, wait a minute. Oh, cannot be oh, it's a warning that it's giving us. What is it saying there? Oh, it's telling us it cannot compute exact p-value with ties. Okay, so it worked. Let's see, but it's telling us it's not going to be exact. I think there's another option we can put in here that allows it to simulate the p-values, I believe by possibly bootstrapping. I may be wrong on that.
right. Okay.
Let's have a look here. Oops, no, we want to see the thing. So it does give us a p-value, okay?
Okay.
It's telling us it's not exact, but I'm imagining if that option is available here, let's see, comma, simulate. No, it doesn't, I don't think it's an option here.
Okay. Oh,
Uh,
simulate at the bottom there.
it's supposed to be simulate p-value, I think, or
Oh, right.
something
Okay.
like that. Yeah, I think it might be part of another test.
Okay. That's fine.
Simulate. Okay. But I've seen it, that these values, because there's some ties, okay, um, it's not going to give us an exact value, but it's never really far off of what it should be.
Sure.
Okay, so sometimes we could, when warnings come up, error, when we have an error, there's an error. But sometimes we get these little warnings. It doesn't mean that we can't necessarily use our data as long as we mention that, it may not be exact because of the amount of ties.
Sure.
All right, what do you think?
I think that was pretty good.
All right, cool, cool,
Yeah,
cool. Excellent, excellent. All right, so that was fun as usual.
indeed.
Okay, and I'll see you next time, all right?
Wonderful. Thank you very much. Okay.
Talk to you soon. Bye-bye.
Bye.
Bye.